Hi, I'm Ethan, an HBA2 student at the Ivy School of Business, and I'll be taking you through an introduction to decision trees and expected value calculations. So to start, I want you to imagine a coin toss. Heads, you get $50, and tails, you give me $20. If we only flip the coin once, then sometimes you'll get $50 and sometimes you'll lose 20. But before you make that decision, you should be able to see that it's a pretty good deal for yourself. You have a roughly equal chance of winning or losing, and a win has a much greater reward than a loss. Expected value lets us formalize this. So what we do is we multiply the probability of events occurring by the gain or loss of those events actually occurring. In this case, we would say 50% times a $20 loss plus 50% times a $50 gain, which nets out to an expected value of $15. Now, you'll never get $15 in this game if you only play it once. But what this calculation shows is that on average, if you took this deal over and over and over again, you'd average out to about a 15 gain per coin toss. We can show expected value calculations by using decision trees. Decision trees are a way of visualizing all the different futures we could find ourselves in and their associated probabilities. We do this because even when making good decisions, there's a chance things can go wrong. And when making bad decisions, there's a chance things can go right. Showing all these different paths in a decision tree, along with their associated benefits, can give us a sense of which decision has the highest value on average. A decision tree can then use expected value calculations to figure out what decisions on average have the highest expected value and guide your decisions. To keep with our coin toss example from earlier, assume I offer a similar game. Heads, you win money. Tails, you lose money. But this time I give you two different options. If you pay me $20 up front, we'll flip a coin and I'll give you $60 if it's heads. And if it's tails, I give you nothing but I keep the $20. Or option 2 is you pay me $50 up front. And on a heads, I'll give you $90, and on a tails, I give you nothing, but I keep your upfront payment. Try and do those same expected value calculations for yourself. When you do them, you'll see that option 1 has an expected value of $10, whereas option 2 has an expected value of negative $5. So this suggests that, on average, option 1 is going to be the better choice for you. So as a note of caution, what I've said here assumes that you want to maximize expected values and nothing else. Imagine the same coin toss where winning gives you $10 million and losing means you owe me $1 million. In expected value terms, this is amazing, but you might not have $1 million to spend or give me, and to owe me $1 million would ruin your life. What I'm trying to say is we need to use our best judgment here. Expected value calculations can be useful, but don't blindly follow them. Much of their value is in formally quantifying the degree to which you believe events will happen, not necessarily telling you what to do if your only goal was maximizing.